Hello students, let us learn the Laplace transform of periodic functions. For any function f of t which is periodic with period capital T, the Laplace transform is given by 1 upon 1 minus e raised to minus st into integration from 0 to t e raised to minus st f of t dt. So here outside we have 1 upon 1 minus e raised to minus s into capital T, where capital T stands for the period of the function. Again, integration is taken from 0 to the period of the function, whereas inside the integrand consists of e raised to minus s into the variable t, not the period t. Let us consider an example. Find the Laplace transform of the periodic function f of t defined as t in the interval 0 to pi and pi minus t in the interval pi to 2 pi. So the function f of t is defined in two intervals from 0 to pi and again from pi to 2 pi. So even if the periodic function is not mentioned, then it is understood that the function is periodic whenever the function is defined only in a interval. Otherwise it will be given like t greater than infinity, then it is a usual function. But here function is defined only in the interval, so that interval is taken as the period of the function. So the period here is 2 pi because total interval is from 0 to 2 pi. Period of the function capital T is 2 pi. Now let us write the Laplace transform of the periodic function. By definition we have this. Now we'll substitute the values. Capital T is 2 pi. Again, the limit capital T is 2 pi here. E raised to minus st will have, then f of t is also kept as it is because throughout the interval 0 to 2 pi, function f of t is not same. So what we need to do is we need to split this interval of integration. We'll split it from 0 to pi because it is defined 0 to pi as t and again pi to 2 pi as pi minus t. So we'll split the interval from 0 to pi and again from pi to 2 pi. Here we have e raised to minus st. The function f of t in the interval 0 to pi it is t, and again from in the interval pi to 2 pi the function is pi minus t. Now 1 upon 1 minus e raised to minus 2 pi s we are kept as it is. Let us integrate this by taking Bernoulli's rule. T is kept as it is. Integration of e raised to minus st, it is e raised to minus st divided by minus s. Derivative of t is 1. Then integration of this e raised to minus st divided by minus s. It is e raised to minus st divided by minus s whole square. We'll stop the integration here because derivative of 1 will be 0. Now limits are from 0 to pi. This completes the evaluation of the first integrand. Now we'll go for the second integral. Function is here pi minus t into e raised to minus st. Again we apply Bernoulli's rule. Pi minus t will keep as it is. Integration of e raised to minus st. It is e raised to minus st divided by minus s. Then minus sign. Derivative of pi minus t. It is minus 1. Integration of this integrated term. Minus s will be constant. Integration of e raised to minus st. It is e raised to minus st divided by 1 more minus s. So it is minus s whole square. Limits are from pi to 2 pi. Let us substitute the upper limit and the lower limits in the two integrals. So 1 upon 1 minus e raised to minus 2 pi s, we will keep it as it is. Now substituting or before substituting, I simplified these terms here. Minus s is there, so that minus is taken here. Minus t e raised to minus st by s. Then because of by the formula we have minus here, it is e raised to minus st by s square. Then plus we have t minus pi e raised to minus st by s. Because here you have minus s, instead of pi minus t, here we are written t minus pi multiplying by minus. Then here minus uh, into derivative of this minus t will be minus 1. So minus of minus it becomes here plus. Now let us put the limits. Pi if you put here becomes minus pi e raised to minus pi s by s. Then here it is e raised to minus pi s divided by s square. Okay. Then if you put 0, this term becomes 0. Then when we put it in the second term, it is e raised to 0, that is 1 divided by s square with the minus sign. So minus 1 divided by s square. I'll go for the second term. Substituting upper limit 2 pi. 2 pi minus pi, it is pi. E raised to minus s into, we have t as 2 pi, divided by we have s, then plus e raised to minus s into 2 pi, then again divided by s square. Now we'll go for the lower limit, so minus sign. If you put pi here, pi minus pi, it becomes 0, so first term becomes 0. If we put pi in the second term, it is e raised to minus pi s divided by s square. Let us simplify this. It is minus pi e raised to minus pi s by s. Again minus e raised to minus pi s by s square. Here minus of minus, it is plus 1 by s square. Then here pi e raised to minus 2 pi s by s. Here plus e raised to minus 2 pi s by s square. Then minus e raised to minus pi s by s square. So we have 1 divided by s square into 1 minus e raised to minus 2 pi s is there, which can be written as e raised to minus pi s whole square. Then here we have this one term here. We'll take LCM. Everywhere you have s and s square. So LCM will be s square. Now 1 is written first. Then uh, e raised to minus 2 pi s here, this term. Then e raised to minus pi s with minus sign, and again e raised to minus pi s with minus sign. Both are divided by s square. So if we add them, we'll get minus 2 divided by e raised to minus pi s. Then uh, this term we have pi into e raised to minus 2 pi s. Taking LCM, it becomes pi s into e raised to minus 2 pi s. Similarly, if we take LCM, here it is minus pi s into e raised to minus pi s. Now, these three terms together can be written as 1 minus e raised to minus pi s whole square. And from these remaining two terms, we can take pi s and e raised to minus pi s outside common. Then here we are remained with e raised to minus pi s. And this whole term is outside. We are remained with only minus 1. Now here also in the outside term, it is in the form of a square minus b square. We'll write it as a minus b into a plus b. Now here in these two terms, we can see that 1 minus e raised to minus pi s whole square is there. If we take minus outside from this, then again it is also 1 minus e raised to minus pi s. So we can keep this as a common term outside, 1 minus e raised to minus pi s. Denominator as it is will keep. Then this one term is outside, we are remained with 1 minus e raised to minus pi s. Then since we are taken minus outside, we are remained with minus pi s e raised to minus pi s. So here these two terms will get cancelled. We are remained with 1 minus e raised to minus pi s minus pi s into e raised to minus pi s divided by only s square into 1 plus e raised to minus pi s. Now in these two terms, you can take e raised to minus pi s with minus outside and simplify and write. Thank you.